Hi, this video discusses optimal inputs choice for a firm whose goal is to cost minimize. I'll show you two different approaches that you can use to answer the question on, in this example, is the firm cost minimizing? If not, what advice do you give the firm on how to reallocate their inputs? So here's the situation. You've got a company that's using 4 units of workers and 4 units of capital. You have marginal productivity of labor being 20 and marginal productive capital being 10. And the question is this firm optimizing? You also need to know the cost of the inputs, because without the cost of the inputs, you can't answer this question. So given that the wage rate is $40 and the rental price of machines is $10, is this firm optimizing using 4 workers and 4 machines? So first, let me provide an intuitive approach. Who is more productive, a worker or a machine? Well, you'd say, oh, your workers are more productive. They get you an MPL of 20, which is bigger than MPK of 10. Yes, that's true. Your workers are twice as productive as your machines. Their MPL is 20, the machine's MPK is 10. What is more costly, using a worker or using a machine? Well, if you've got to pay your workers $40 and your machines 10, workers are clearly more expensive. How much more expensive is a worker? Well, they're 4 times as expensive. So let me recap. Workers are twice as productive. Workers are 4 times as expensive when you have 4 workers and 4 machines. So, is this company optimizing? Clearly not, because what you want to do is have your ratio of marginal products be equal to your ratio of input costs, wages, and rental prices. So that's the intuitive approach. Now, let's use the Tangency Rule to determine if the firm is optimizing. And recall what we needed for the Tangency Rule is the slope of the ISO cost, this line, to be equal to the slope of the ISO quant, this curve. And so 4 and 4 units of workers and 4 units of capital is approximately right here at this blue dot. So there's 4 machines and there's 4 workers right here. And clearly that's not a tangency, that's an intersection. That's your first sign that, hey, this is not going to be the optimal. Because what we want to happen at the optimal is these 2 curves have the same slopes. So no, the firm's not optimizing because this is an intersection point, not a tangency. So if the firm's not optimizing, what do you suggest that they do? If not, what should they do? Well, let's take a deeper dive into this. The slope of the budget constraint, or the ISO cost, okay, this slope is negative W over R. And watch the video on ISO cost to determine how we get this slope being negative W over R. The slope of the ISO quant is this ratio of MPL over MPK. Well, MPL over MPK is negative 2. This slope of this budget constraint, going from 20 down here to 5, that's negative 4. That's negative 4. Okay? Because wages were 4 times the cost as your rental price of a machine. So clearly negative 4 is not equal to negative 2. Or in this case, you have the slope of the isoquant is flatter than the slope of the ISO cost curve. So what do you need to do? You can't change the slope of the ISO cost, but you can change the slope of the isoquant by moving along the isoquant. And how do you move along the isoquant? You use fewer workers, and you're going to use more units of capital. So the firm's not optimizing. They should use more capital. You should use fewer workers. Now, the optimal bundle in this case is going to look something like at this point here, where you're going to use fewer than 4 workers. Okay, this is the optimal level of labor, L star, let's call it. And you're going to use more than 4 units of capital. This is the optimal use of capital. Call it K star. Okay, and at this point, the slopes are equal. The slopes of the isocost, which is -4, is equal to the slope of the isoquant, which will be -4. Okay. And finally, if you use the last dollar rule, or last dollar spent on a capital, last dollar spent on a worker at this initial point here, let's show you why that's not optimal. So the last dollar rule, this is the ratio of marginal product of labor over wage. So that's 20 is our marginal product of labor. And our wage, we said, was 40. So this 20 over 40 gets you 0.5. Or another way to say this is one more dollar spent on a worker gets you a half a unit more of output. What is that corresponding number for machines or capital? Well, the marginal product of capital is equal to 10. So put that in here. Marginal product and the rental price of capital is 10. So you put that in here. So 10 over 10 is 1. Or another way to say this is a dollar more spent on a machine gets you one more unit of output. A dollar compared to a dollar more spent on a worker gets you half a unit of output. Clearly, you want to spend a dollar more on a machine and a dollar less on a worker. So that says your optimal bundle lies to the left of that point. Your optimal bundle lies to the north of that point. And this is the optimal bundle.